In this video I'll show you how to use TypeVar and generics in Python to write cleaner, more flexible and type-safe code. In a nutshell, generics in Python are a way to define functions and classes that can operate on different types while still preserving type safety through type hints. You can use type variables via TypeVar to indicate that certain inputs and outputs are related or consistent in type, without the need to specify exactly what type is. This was a brief theoretical explanation of these concepts, but I feel like the best way to understand this topic is to look at examples and walk through the code. So let's do exactly that. Alright, so let's begin. First things first, let's ensure that type checking is enabled. I use VsCode, and here, if you also use VsCode, you should go here at the bottom right corner where you see Python, click on these curly braces or just hover over them, and here you will see type checking. It might be off for you, so click here, select type checking mode and select basic. Let's import the things that we need. So from typing, import sequence, typeVar and reveal type. You will see why later. Let's define a type variable. And next thing, let's look at the first example. Let's try to define a generic function. So it will be our first function. We call it first. It accepts one parameter called sequence, which is like any sequence in Python, and it will just return the first element in the sequence. And here, as you can see, we are using typeVar, and basically what it means that this function accepts any Python sequence where elements in the sequence are of one type t. And then we return this first element of type t. So we get the sequence of t and then we return t. So as you can see here, we are given it a list of integers, and if we hover over it because of the real type function, we see that type of this expression is integer, because it will return us 1 and it's integer. Let's explore further and look at another example of the generic function, but to be more precise, first we'll look at the function. How would you probably be able to write it if you didn't know about generics? So we have an add function. The idea for this function is to accept two parameters of type either integer or string and then add them. So if both of them are integers, we will get a mathematical sum. If both of them are strings, we should just get a concatenated stream from these two. And it accepts two parameters. And how would you type annotate it? Probably you would write something like this, like it's either integer or string for both parameters, and it returns also either integer or string. But as you can see, our type checker is not happy with that, and this is actually understandable, because essentially what we are saying here, that we can set, for example, a to integer but b to string, and then it would error. So we are not enforcing that a and b should be of the same type, and whatever this type is, it will be the return type also. How would we do it properly? Properly with typeVar and generics, it would look like this. So we have an add function. We type annotated with generic type t. And it can be either integer or string. And then we set it like parameter a is type hinted with t, b is also of type t, and the return type is also t. And like this, our type checker is happy. And if we do it like, if we call it like this, add 1, 2, it works, all is good. If we call it like this with two strings, it will also work properly. But if we call it, for example, in the wrong way like this, you can see that our type checker is not happy and literal a is not assignable to type int. It fails because our type t is bound to integer. I feel like functions are a really great example to get the initial understanding of generics and TypeVar in Python, because it's very simple, it's very short, and you can like clearly see what's going on. But for me, the actual issue when I started learning about generics and TypeVar, it was not with functions. I struggled a bit with understanding of classes and type hinting class to be like a generic class, and this will be like the example that I propose you to look at next. So as an example of a generic class, I propose you to implement a generic queue. Essentially, queue doesn't care what kind of elements of what type does it hold, but it's a common task that we want to have a queue that holds, for example, only elements of this type. And let's do it. I'm gonna implement a queue as a linked list. For that, we will need a node class, and we will define it right away that it's a class node of type t, which means that this node will hold the data of type t. Let's define a constructor. The init method, it will accept the parameter data of type t, which you can also see here, and then we'll just assign this data to the attribute data. So if I hover over it, we will see that data is of type t, and since it's linked list, we are gonna need a pointer to the next node, and this is what's happening here. We define an attribute next of type node of this class of type t, the same type. Or it can be none, which is also fine, because in the beginning our queue will have 0 elements, then only one node, which will not have like the next node to point at. So initially it's going to be none. Alright, I have noticed that it highlights me this type as an error, and I somehow messed up during this demo my Python environment, so I'll just set it to the 3.13, because for some reason it was 3.10, and this syntax is not available, by the way, in 3.10. But we will cover it briefly later. So we have our node, and next let's define a queue. Notice also we define a type, a generic type for the queue here in the same way in squared brackets. Then we'll also have a constructor, of course. Our queue will have an attribute head, tail, and length. Head and tail are of type node, of type t, or none. So again, initially it's gonna be none when the queue is empty. Then when we'll add elements, it will be of type node, and it's the same node as we defined above. And we say that the type of the node will be the same type as the type of the queue, the same generic type and length. So next let's add the enqueue method, which will add elements to our queue. It's gonna accept the data, and notice that we want the data of the type that the queue was defined with. So if we define the queue with an integer, then the enqueue method can accept only integer here. It's our intention. So in the enqueue method, we define our node based on data. Then we check if we have a tail. If we have a tail, then it means that our queue has at least one element, and we will point our previous tail to our current node that we have just created here. And if we don't have the tail, it means that the queue is empty, and it will be the first element in the queue. And then we do common steps like increase length and point the tail of the queue to our newly created node here. Let's add another method called dqueue, which will remove the element from a queue and return it to us. I will skip the explanation of all these logic and just point out that the return type of this function is also of our type var t, meaning the type of the elements that we store in the queue. And let's add the final method to our queue called toList, which would just return all elements from the queue in a form of a list. I have added it just to show you that we can put our generic type t as an element of another generic type list. List is also like a generic type. So we are saying that this function will return a list of elements that are inside of our queue. Alright, so now our queue is ready, and let's initialize it. It will look like this, class name. Then in square brackets we can define a type of this queue. So in this case I want a queue of integers, and it will be empty by default. Let's add a bunch of elements here. Also, all of these elements are of type integer, and as you can see, everything is fine. But if I try to add there a string, our IDE says us that we cannot add a string to the queue of type integer. And this is the whole point of using generics. And let's just call our dequeue method to ensure that everything works as expected. So I'm gonna call it 2025 generics and queue. And as you can see, it worked fine and returned us all elements that we added to the queue. Now let's go a bit deeper and let's say that we want another generic queue, but a numeric queue, like a generic queue that can be of type integer or float. Let's try to do it. And also I'll demonstrate you the differences that were in the syntax before Python 3.12 and starting from Python 3.12. Here you can see how we would define a class, a generic class before Python 3.12. So first we would have to import the generic class and type var from typing module. Then we would have to initialize the type var explicitly here like this. And since we want our type var to be bound to only floats and integers, you would do it like this. And then when we want to define our numeric queue class, we pass here two other classes. So the first class is our generic class that we imported from typing module. And we assign a type t that we created right here to this generic type. And also, of course, our second class queue that we have implemented here above. This is how it has to look like for Python prior to 3.12. And here you can see how the same thing looks like for Python 3.12 and upwards. First thing that I want to point out that you don't need to define this type var separately as we did here. We can just use square brackets right here, t, semicolon, and bound it to types float or integer. And then use standard Python inheritance and inherit from the queue that we have created here above. And also I'll point out that we here pass to the queue this type t. And something else that I want to mention, that constraining t to type float and int like this is not the same as it would be if you did it like this. So basically when we do it with the tuple syntax, we are saying that numeric queue can be of type either float or int, these specific types. But with this syntax, with or, we are saying that numeric queue can be of type float or int, or any child of float or int. So let's add one method to numeric queue. We'll call it total, and it will calculate us the total of all elements in the queue. Let's test it out and initialize it. So we initialize it exactly in the same way as our normal queue. We say the class name, we pass the type of this queue. So we want a queue of integers. And let's try to violate our type hint from the beginning and add here a float, and as you can see, the IDE points out that this is an issue and we want integer here, not a float. And when we try to add an integer, all looks fine and nice. And let's print our numeric q and also the total property of it. And I want to do it just to demonstrate you that despite the fact that we see here this error from PyLens from type checking, in Python this is still just for your information, so to say, because as you can see, it still works despite the fact that this is not how this class was intended to be used, because after all, Python is still a language with dynamic typing, and these type hints are purely informational. So moving on, here is actually the thing that I wanted to test and that I mentioned already, related to this tuple-like syntax for types versus using or here for types. So if you remember my explanation, I said that when we do it like this, we are basically saying that we want numeric q to be of type specifically float or integer, not some other child of float and integer. And that's actually how it should work from what I read, but to be honest, I wasn't able to make VsCode to highlight it to me as an error, because here, as you can see, I have defined a dummy myFloat class that inherits from float, and then we are able without any issue to initialize numeric q with type myFloat. Despite that, with that syntax, it shouldn't work. But yeah, it works and no error is highlighted. Just as a proof, I'll show you quickly that it really works here as well. Yeah. As you can see, all good. Moving on, if I try to set a type string to our numeric q, IDE says to me that that's not how it was intended to be used, and I cannot set string type to our numeric q. But again, as I said, it's purely informational for us as a developer, because if I run it, if I run the script, this query will be successful. This query will fail because our numeric q will have a string ABC inside of it. So obviously mathematical operations to calculate the total are not possible. Yeah, so let's quickly check. I run it again. And as you can see, this line numeric string q ABC was successful. And then we got an error while calculating the total because we have a string. And finally, I want to show you one more thing related to differences before and after Python 3.12. This thing is related to type aliases. So here you can see how would you define a type alias before 3.12. So we would have to import this type alias class from typing, again define our TypeVar here. And if we want, for example, a type that is either list or set, we would do it like this. So list or set of type alias, which is equal to list with type t with typeVar t or set of typeVar t. And this line below is how you can achieve the same thing, but starting from Python 3.12, very more concise, just use the word type, then the name of the type alias that you are creating of type t. And yeah, it can be equal to list of type t or set of type t. If you want to play around with the script that I showed in the video, in the description you'll find the link to GitHub. What are your thoughts on generics? Do you find them useful or not? Did this video help you to understand them better? I really hope that it did. Let me know in the comments, I would be very curious to know what you think about them. If you are still struggling a bit with them, that's totally fine. For me it also took quite a time to wrap my head around it, and for me it really helped to open the editor and try them out myself. So that's specifically what I can recommend you if you are still struggling with them. YouTube thinks that you might like this video. Give it a try and let's see what you think. If you enjoyed this one, subscribe for more content like this. Thanks for watching and happy coding!